In order to raise the company's profile and engage audiences, research into visualization experiences within the automotive industry was essential. The findings suggest that consumers now begin their buying journeys online, and that visualization of the vehicles is one of the most important factors affecting decisions. At Autorouge experience has shown the results of high-quality 3D panoramas of vehicles to be viewed 40% more than flat images. A new report from Cox Automotive suggests consumers want convenience, with only 1 in 3 being very satisfied with the current dealership model, demonstrating the need for improvements. The research tells us that they want the service to be convenient, personalized, and easy, based on their preferences and schedule. In line with these needs, I've decided to create a car visualizer which allows the car buyers to browse and compare vehicles from the comfort of their homes. Quantum Motors is an automotive company that has car dealerships dotted around the UK. Their vision is to revolutionise the future of driving through innovation and a strong commitment to sustainability. They've become known for their use of advanced battery technology and futuristic designs. Quantum Motors is developing an interactive web-based car visualizer as a key part of their marketing strategy. This tool lets users explore vehicle features, customize cars, and experience virtual driving, aiming to establish a deeper connection with potential buyers. To get a feel for the target user, a mood board was designed. Our user is Eric, who's 33 years old, co-owner of a law firm in Scotland. He's looking for a new car, but is very busy and doesn't want to waste time going around multiple car dealerships. I created a user scenario for the interactions that Eric would carry out with the application. From this research, 3 important design decisions had been made to suit our audience. I really like the piece designed by Vincent 091036. Although only displaying one model of the car, the user could configure the model, such as changing the colour of the body details or glass. Allowing the user to personalise their vehicle saves time and could lead to higher sales conversions. The interactive piece used all 3 mouse buttons for inputs. The second car visualizer was created by Lamborghini. This featured high-quality renderings of the inside and outside of the vehicle, buttons that triggered car animations to provide users with further information on the model, and the option to experience through AR on mobile devices. This more advanced visualizer engages the users well through multiple opportunities for interaction and learning, meaning the user is more likely to be excited to explore the model. It uses less left mouse button and middle mouse button as inputs. Research was then carried out to determine the best way to design the piece for successful interactions. I looked into Ben Schielderman's book, where he reveals his 8 golden rules of interface design. For example, consistency is one rule I have followed by using a familiar button shape and colour for all my buttons in the piece. Another rule is to offer informative feedback. I've done so by designing the buttons to have a ripple effect, providing visual feedback to the user, indicating the button is interactive. Audio feedback is triggered by the button being interacted with in the form of sound effects. I've also offered easy reversal of actions by keeping the 3 model buttons available at any point so users can go back if they change their mind and want to view another model. As Schielderman states in his book, this feature relieves anxiety since the user knows that errors can be undone. It thus encourages exploration of unfamiliar options, reduce short-term memory load. Another rule followed was to reduce short-term memory load by presenting the name of the car models on the buttons instead of model 1, 2, 3. The user only has to recognise which model of car they want to view, rather than recall from memory which button is which car model. There are 3 key features to this piece. The first is the mouse interactions. The user can view the car models of any angle and distance using the mouse buttons. In summary, the Orbit Controls instance allow users to navigate the 3D scene using the mouse, enabling zoom functionality and smooth camera movement. The controls are updated in each frame, ensuring responsiveness. The next key feature is the display port of the vehicles, used to view the different models and navigate around the scene. Set up using the scene, camera and renderer in the init function. The canvas element where the renderer draws is specified and the scene is continuously animated in the subsequent play function. Lastly, the 3 buttons related to the 3 available car options are created within a div, each with unique IDs and classes for styling purposes. I then attach event listeners to these buttons to handle user interactions. Additionally, within the change state function, specific actions are taken based on which button was clicked, such as adding or removing models from the scene. The mouse and keypad are the only possible input devices for the prototype at this stage. The physical mouse can be used to control the position of the cursor on the screen, to select interface elements such as different state buttons, and for orbit control. The keyboard buttons can also be used to navigate the 3D environment. I'm happy with the created project as it fulfies the brief and allows the user to explore the car models. It is interactive and provides visual and auditory feedback successfully. In the future, I'd like to be able to develop this prototype further by including configuration options for the car bodies and details, having a 360 view from the inside of the vehicle as well as additional information points may enhance the user experience further and lead to higher sales for the company.